Okay, so for my video corrections, I am doing problem 7, which I got a significant amount of points off of. So I did part A correctly by sketching out each of the events. So event 1 before the collision, event 2, which is the collision, and then event 3, which is after the collision, when so event 1, the car was initially stopped and the train was moving with a certain velocity, which is one of the variables that you find for part B. And then event 2 is during the collision when the two objects are colliding. And this is when the car, I guess, gains velocity from the train, and it's no longer at rest. And then event 3 is when the car has come to stop again after moving 10 meters after the collision, and both the train and the car are stopped. So to set up the problem, initially I set up the left side correctly by setting it up as event 1. Obviously, the train is the only object that's in motion, so the car variable would cancel out on that side. So, but then I set it up kind of with event 2 in mind, where I thought that the objects were touching, so the variables would, I guess, be added together in the formula, which this turned out to be wrong. I set it up this way because I got lost in the wording, honestly, because it says how fast was the car moving just after the collision. So I was thinking a little bit before event 3 because the car came to a stop, and I was thinking there was something in between event 2 and event 3. So and then for the second part, like how fast was Thomas moving just before the collision, I was more confident in setting up that side, which I got correct. But the right side I was pretty confused on. So I later found out that, so I wrote out everything here, how it's supposed to be done correctly. So, writing it out the left side like I did before, this is when the train is in motion and the car is at rest because it's looking for how fast was the car moving, how fast was the train moving just before the collision. So, and then the right side is how fast, I'm trying to find how fast the car was moving just after the collision. So at this point in time, the train has abruptly stopped and it's no longer in motion. So the car would be the only object in motion. So that's why the train is not on this side of the equation. So I learned that you're supposed to look at it as event 3. You're supposed to be finding the initial velocity of the car, and I was looking more in terms of the final, because it stopped. So I was thinking there was an event in the middle where the car had a velocity, but you're supposed to try to actually find the initial velocity of the car. So I later set that up to where mt times vti equals the mass of the car times the velocity of the car initially in event 3, and then the left side would be event 1. So knowing that I have two unknown variables, I tried to find one at a time. So I started off with the velocity of the car, and I plugged it into the F equals ma formula, and I knew that it gave me a coefficient of friction of the car. I believe, what did the fuck say? Yeah, it just says the measure coefficient of the kinetic friction between the car and the railroad was 0.62. So I used that for the car, and knowing that like there was no active force acting on the car because it was sliding to a stop in that 10 meters. I the only force that I used in this was the friction force, and since it was going against the direction of motion, I set it up to be negative. So I set that equal to mass times acceleration, which, breaking it down, would be the coefficient of friction times the normal force, which I found by obviously multiplying the mass times the acceleration of gravity. So plugging in those variables, I am trying to find the acceleration of the car, and so I ended up getting negative 6.0822 as acceleration. So with that, I plugged it into the kinematics equation, where since I'm trying to find the initial velocity of the car, I cancel out the final, and obviously I have all the other variables I need, so I multiplied 2 times the acceleration times delta x, which in the problem it stated that it takes 10 meters to slide to a stop. So I plug those variables in, and then I square rooted that side, and then I ended up getting 11.03 meters per second as the initial velocity of the car, which I then plugged back into the equation to simply find the velocity of the train just before the collision in event 1. So finding the second variable, it's just you plug in the variables into that equation, and then you just find the velocity of the train. So you can double check both of them by, say you want to check to see if the velocity of the car is correct. You can plug this back into the equation to see if there are any calculation errors. So that's basically how you solve question 7.